Welcome to our training session on how to extract vibrational information from a Phantom Cine file using the Cine Analyzer module track and measure. So the first thing I'm going to do is choose a Cine file that I would like to analyze. So here I have a fan blade, okay, and upon inspection inside of my Phantom camera control software here, I can notice as this fan rotates very quickly, you can look at the top of the fan and you can see some very interesting vibrational behavior here induced by that rotation, right? So you can essentially see that we have a vibration at the very, very top. So what we're going to go ahead and do is use the Cine Analyzer package to extract and study that vibrational information. All right, so what we're going to do is we're going to go ahead and click our track button here, okay? And we're going to go ahead and select a feature that we want to use to extract this vibrational information, okay? So we have some very well-defined dots up here, so we can kind of pick anything we'd like. So I'm going to go ahead and click on this object right here, all right? And if I wanted to, I could even, I can use this magnifier tool to even get much closer to see really what I'm looking at. And this is the marker that I'm gonna track in time, okay? And I'm gonna go ahead and call it a speckle 1. All right. And notice that my speckle is a lot smaller than my template area, so I don't need that big of a template area. So I'm going to go ahead and open my auto track dialog, and I'm going to go ahead and make my template size 20 by 20 pixels approximately here, okay, which is a reasonable size. And then I'm going to shrink my search area to around let's say 31 by 31 here, okay, and update that. So this looks pretty good. I'll be able to track across. I'm going to turn off update template because I don't have much template change in time, so it's going to be pretty consistent. And I really want to see what the nuanced movement is during this vibration. So I'm going to go ahead and do an interpolation of 1/10 of a pixel, and I'm going to go ahead and run this. All right, and basically what this processing will do is look at every single frame in this video series, and it will analyze it. So in a second here, it will be complete. All right, so it looks like we have some really nice information down here at our displacement versus time graph. So we can play it back, and it's completely invisible to the eye if you look at it from the normal view, but on the right-hand side, you can see it in that magnified view. You can see it oscillating back and forth, left and right. All right, so clearly there's some left and right movement. So X looks like a sinusoid, and then we have some Y displacement there. Because we are so close to the pixel pitch here, we have really no motion in the Y direction, really just 3 essentially steps here, even with our subpixel analysis. So if we go now and we click on the X vibration, where most of the motion is happening, we can go ahead and analyze the DFT output. So we get a really strong, obvious peak down here at 24 hertz. So really interestingly, this is oscillating roughly at the frequency of the rep rate of the fan blade. So it looks like it's in a good resonance. And now let's do a deeper analysis. So I'm going to go ahead and see if this vibration is in any way related to the rotational rate of this fan. So I'm going to go ahead and add a marker here to this circle marker here. And I'm going to go ahead and just do create a template image such that it encircles, or rather encases, this circle marker. Search area is reasonable here. Okay, and what I'm going to do is I'm going to lower the score because I do have speckles in the background, and if I don't update the template, then it will indeed stop the track. So I'm going to go ahead and process this. All right, so it looks like I have a nice track of this circle marker as the fan rotates. So if we take a look at the X displacement down here, it looks like the amplitude is clearly larger in the case of the fan's marker, which makes sense. You have this pretty large length here that you're rotating about, and then we have the smaller amplitude here for our vibration. So if we pop this out here, we can start to study this, right? So the question is, in my head, is this fan resonating or vibrating with the rotation of this blade? So to see that, I'm going to go ahead and try to zoom in as much as I can using the window zoom feature. And if you really look, you can kind of see that indeed this vibration is, at least for that marker, oscillating exactly out of phase with that particular marker. Okay, which is very interesting. So it does make sense now that we are getting a vibrational mode in the X direction at the top that is equal to that of the rotation rate of the fan. So really interesting analysis here. So if we wanted to go ahead and export this data and take a look at it in the form of a PDF, we can go ahead and click export. All right, and save it to my desktop as, we'll call it vibe. Okay, so here I have the name of my file that I tracked, the metadata from the test, the resolution of the Cine file. If I scroll down here, it shows that tracked points, the area that I analyzed. And as I go down, I can see what is the template image that I used to track. There it is right there. I can see what my displacement versus time looked like, okay? And I can get some speed information, approximation, and then importantly, I have here my frequency spectrum for what my oscillations are in the X direction, and then I have also some information about my Y direction as well. So this was a really short tutorial on how to extract vibrational information from the Cine Analyzer package. I look forward to the next tutorial. Thank you.